Good morning, gentlemen. Hope you are doing good. Today in this video, we are going to learn Lorentz transformation equations and inverse Lorentz transformation equations. So, first of all, let us make diagram of inertial and non-inertial frame of reference. So, this is point Y, this is Z-axis, and this is X-axis. These are the coordinates or axes of stationary frame of reference, and this is point Y dash. This is coordinate or axis Z dash, and this is X dash. These are axes of non-stationary frame of reference S dash. Now suppose a point P in this inertial frame of reference, when it is seen from the inertial frame of reference, then we have points or coordinates x, y, z and t. When it is seen from the non-stationary frame of reference, then it has coordinates as x dash, y dash, z dash and t dash. This is point O, this is point O dash. It has r dash vector or r magnitude. This is it has r dash. Now we know that time is equal to distance upon speed, implies t equal to r dash upon c, where c is speed of light, implies t equal to under root x square plus y square plus z square upon c, implies c square t square equal to x square plus y square plus z square, implies x square plus y square plus z square minus c square t square equal to 0. And this is our equation number 1. Similarly, for non-stationary frame, we have x dash square plus y dash square plus z dash square minus c square t dash square equal to 0, and this is our equation number 2. From equation 1 and equation 2, we have x square minus c square t square equal to x dash square minus c square t dash square, and this is our equation number 3. Because we know we are working in x axis, implies y dash equal to y and z dash equal to z, and that's why they cancel out each other in equation number 1 and 2, and we are left with x square minus c square t square equal to x dash square minus c square t square. Now moving forward, we have now from transformation equations, we have x dash equal to lambda x minus vt, which we derived in our previous classes, and this is our equation number 4. Now x equal to lambda x dash plus vt dash, this is our equation number 5. Now from equation 4 and equation 5, we have x equal to lambda into lambda x minus vt plus vt dash. Putting this value here, we will get this. Now x equal to lambda square x minus vt plus lambda vt dash, and we get the value of t dash as x minus lambda square x minus vt upon lambda v. This is our equation number 6. Now moving forward, we have from both the equations x square minus c square t square equal to lambda square x minus vt whole square minus c square lambda square v square into x minus lambda square x minus vt whole square, and we get this from our equation number 3, which is x square minus c square t square equal to x dash square minus c square t dash square. So we have put the value of x square minus c square t square equal to the value of x dash square, which we have find here, and then putting the value of t dash square we have find here, which is our equation number 6. Now moving forward, we have to compare the coefficient of t square, and we get minus c square equal to lambda square into v square. So it becomes minus of lambda square v square equal to minus here we will get so we will left with, when we multiply this, as we are considering only the coefficient of t square, so x square is not of our use, and same with the case of x. So here we will left with, when we multiply this it becomes c square v square t square lambda की power 4 upon lambda square v square. So v square cancel out each other and becomes lambda square. So the coefficient of t square becomes c square into lambda square. So it becomes c square into lambda square. Now we will from this equation get the value of lambda, which is lambda equal to 1 upon 1 minus v square upon c square under root. Now as we have find the value of lambda, we have to put this value into the equation of x dash, which is our equation number 4, and we will get the value of x dash as follows. So x dash equal to lambda x minus vt implies x dash equal to x minus vt upon 1 minus v square upon c square under root. This is the value of x dash, and y dash equal to y, because we are working only in x axis, and z dash equal to z. And similarly, as we have already find the value of t, then t dash equal to 1 upon 1 minus v square upon c square under root into t minus vx upon c square. And for inverse Lorentz transformations, we have to change the sign of these equations, like for inverse Lorentz transformation, x dash becomes x plus vt upon 1 minus v square upon c square, and actually it is x become x dash plus vt dash, and our t become 1 upon 1 minus v square upon c square under root into t dash minus v x dash upon c square. So gentlemen, this is all about this topic. Hope you understand this topic. If you want any numerical on this topic, do comment below, and please subscribe to my channel, like the video and share among your friends. If you have any suggestion and want any separate topic to be discussed here, do comment below. In our next video, we will learn length contraction and time dilation. Thank you.